Welcome to this video on Terraform State Management, part of our Cloud Infrastructure as Code series. Today, we'll explore how Terraform tracks your infrastructure resources and dive deep into state files and remote backends. Understanding state management is crucial for working effectively with Terraform, especially in team environments. Terraform State is a JSON file that acts as a bridge between your configuration code and the actual resources deployed in the cloud. It serves multiple purposes. First, it maps your Terraform configuration to real-world resources. Second, it tracks resource metadata and dependencies to understand relationships between components. The state file is refreshed during plan and apply operations to stay synchronized with reality. Finally, it enables fast lookups, allowing Terraform to check resource status without querying cloud providers every single time, which significantly improves performance. Let's look at the structure of a Terraform state file. It's a JSON formatted file containing several key elements. The version field indicates the state file format version, currently version 4. The Terraform version field shows which Terraform version created this state. The resources array is the heart of the file, containing all managed resources. Each resource entry includes its type, like AWS instance, its name from your configuration, the provider information, and the instances array with actual resource attributes, such as the resource ID. This structure allows Terraform to precisely track every component of your infrastructure. By default, Terraform uses local state, storing everything in a file called terraform.tfstate in your working directory. Local state has some advantages. It requires no configuration and is perfect for learning and personal projects. However, it has significant drawbacks for production use. There's no support for team collaboration, as the file exists only on your machine. There's no locking mechanism, which can lead to conflicts if multiple people try to work simultaneously. And there's a real risk of data loss if your local machine fails or the file gets corrupted or accidentally deleted. Remote state solves the limitations of local state by storing state files in a shared, centralized location. This approach offers several critical benefits. First, it enables true team collaboration, with all team members accessing the same shared state. Second, it provides state locking to prevent conflicts when multiple people are working simultaneously. Third, it offers enhanced security through encryption both at rest and in transit. And fourth, it includes automatic backups and versioning, allowing you to recover from mistakes or rollback changes when needed. For any production environment or team project, remote state is essential. Terraform supports numerous remote backend options to suit different environments. AWS S3 is widely used, paired with DynamoDB for state locking. Azure Blob storage provides native locking capabilities built in. Google Cloud Storage, or GCS, is the natural choice for Google Cloud projects. Terraform Cloud is HashiCorp's managed service, offering additional features like remote execution and policy enforcement. Consul, another HashiCorp product, provides service discovery along with state storage. And even Postgres database can be used as a backend option. The choice depends on your existing infrastructure, team preferences, and specific requirements. Let's examine a practical example of configuring an S3 backend. Inside the Terraform block, you define a backend of type S3. The bucket parameter specifies your S3 bucket name for state storage. The key parameter defines the path within the bucket, useful for organizing multiple projects. Region specifies the AWS region where your bucket resides. The encrypt parameter, set to true, enables server-side encryption for security. Finally, the DynamoDB table parameter specifies the DynamoDB table name used for state locking. This table must be created beforehand with a primary key named lockID. This configuration ensures your state is secure, centralized, and protected from concurrent modifications. State locking is a critical feature that prevents multiple users from modifying the state simultaneously, which could cause corruption and conflicts. Here's how it works. When someone runs Terraform apply, Terraform automatically acquires a lock on the state file. This lock blocks any concurrent modifications by other team members. They'll see a message indicating the state is locked and who holds the lock. Once the operation completes successfully or fails, Terraform automatically releases the lock, allowing others to proceed. This mechanism ensures only one person can modify infrastructure at a time, maintaining state file integrity and preventing race conditions. Terraform provides several commands for managing state files directly. The Terraform statelist command displays all resources currently tracked in your state file, giving you a quick inventory. The Terraform state show command reveals detailed information about a specific resource, including all its attributes and current values. The Terraform state move command, or MV, allows you to move or rename resources within the state, useful when refactoring your code structure. And the Terraform state remove command, or RM, removes resources from state management without destroying the actual infrastructure. This is helpful when you want Terraform to stop managing something while keeping it running. Let's see these commands in practical use. To show specific resource details, you run Terraform state show followed by the resource address, like ozinstance.web. This displays all attributes of that EC2 instance. To move a resource to a different module during refactoring, you use Terraform state move with the old address and the new address, such as moving ozinstance.web into module.ec2.ozinstance.web. To remove a resource from state management while keeping the actual resource running, you use Terraform state remove followed by the resource address, like ozinstance.oldserver. These commands give you fine-grained control over your state without touching actual infrastructure. Proper state management requires following security best practices. First, always encrypt your state files both at rest and in transit. State files contain sensitive information like passwords and API keys. Second, never commit state files to version control systems like Git. They contain secrets and can grow large over time. Third, enable versioning on your backend storage. This provides rollback capability if something goes wrong. And fourth, restrict access to state files using the principle of least privilege. Apply strict IAM policies, ensuring only authorized team members and services can read or modify the state. Following these practices protects your infrastructure from security breaches and accidental damage. Let's recap the essential points about Terraform state management. State files are the crucial link that maps your infrastructure configuration to real resources in the cloud. Remote backends enable effective team collaboration through features like state locking and encryption, making them essential for production environments. Terraform state commands provide powerful capabilities for resource management, allowing you to inspect, move, and remove resources as needed. And security must always be a priority. Always secure your state files with encryption and strict access controls. Master state management, and you'll have the foundation for reliable, scalable infrastructure management. Thank you for watching, and see you in the next video of our Cloud Infrastructure as Code series.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.